Yeah, so we want to work some more word problems. It's going to be our word problem number 3 here. And we have it written down already. It says, after an 8% increase this past year, the population of a city is now 116,694. What was the population at the beginning of the year? Okay, so you're going to read that and make sense of it. So that's our kind of step 0. Read and make sense of. Problem. Yeah, so here we really can't draw a picture, right? There's no geometric situation, no triangles, no rectangles, etc. You just have to think about what's happening. So the idea is you're starting off with the population in the city. We don't know how much the original population is. And the population is going to increase by 8%. And at the end of this year, we're going to have 116,694 people. So we want to find what's the starting population. So here we want to declare our variables. So step 1, we don't want to declare the variables. What quantities are we trying to find that are unknown? It turns out there's really only one thing we're trying to find here, and that is the population, right? What was the population at the beginning of the year? We're going to call P the population at the beginning of the year. Population at the beginning of the year. That's what we're looking for. That's the only thing we're looking for. The next thing we want to do, I'll call this step 2. We're going to write our equations. We're going to get our equations from our sentences. So if you read the first sentence, we're going to have an 8% increase in population. So after this 8% increase, the population is going to finally be 116,694. So we start off with 100% population, right? You always start off with your total population, which is 100%, and you're going to go up 8%. Up 8%. So what's 100% plus 8%? An increase in 8%? That's 108%, right? So 108% of your population, that's times your population, is going to be 116,694. So 108% we write as 1.08, right? 1.08. That's 108% of our original population. Our starting population, P, is going to be equal to 116,694. And that's the only equation we have here. That first sentence gives us that equation. So if I want to solve that equation, let's solve step 3. I have 1.08 P equals 116,694. If I wanted to solve that equation for P, I'd divide both sides by 1.08. The 1.08s would cancel, and I get P is, well, whatever P is, and take 116,694 and divide it by 1.08, and you get P to be 108,050 people. So your population would have started out at 108,050, and it would have gone up by 8%. Going up 8%, that means 108% of the original population to 116,694. All right, let's do another word problem. Another word problem. There's going to be an age problem. John is 7 years older than Sam. In 5 years, John will be twice twice. Twice as old as Sam. How old are John and Sam right now? How old are John and Sam right now? Okay, so we read that sentence, those sentences, 3 sentences, right, and it makes sense. Read and make sense. Of the problem. So we really don't have a picture to draw here. We don't have any rectangles or squares or circles or triangles or anything. It's kind of a riddle, I guess. So let's declare our variables. Step 1, declare variables. What are we looking for? How old, right? John is right now and Sam is right now. So we're going to call J John's current age. And S we're going to call Sam's current age, so right now. So those are the 2 unknown quantities that we're looking for. So I want to write some equations for this. So step 2, write equations. So this first equation is going to come from the first sentence. Let me see, what color do I want to put this in? I'll put in like a purple color. It's going to be equation 1. So right now, John, that's J's age, John's age, is equals 7 older than Sam. So that's Sam plus 7, right? 7 older than Sam is Sam plus 7. That's current. So the next equation, what color do you want to do that in? We'll do that in maybe like, come on. I don't know what's going on with my thing here. Orange will be my second equation. Get that from the second sentence. This is going to be a future, right? Future, 5 years. This is going to be in the future, not current, 5 years. So I'm going to write here, the first equation was current. The second equation is going to be future tense. Right, 5 years in the future. So the second equation here is in the future, 5 years in the future. So John will be, what's John's age in the future? J plus 5, right? J plus 5 is John's age in the future, 5 years in the future. John's age in the future, J plus 5, is going to be twice as old as Sam's age. So 2 times Sam's age. What's Sam's age in the future? S plus 5, right? Sam's going to be S plus 5 because it's 5 years in the future. So John's age in the future is going to be twice Sam's age in the future. That's J plus 5 and S plus 5 respectively. Okay, so we got these 2 equations. Now we want to solve here. Solve, 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 solve. Okay, what color am I going to solve with? Okay, I'll use this lime green to solve. 3. Solve. So what I could do, I could take for J here, this J right here, see this J? We could plug in place of that J, we could put, instead of a J there, we could put S plus 7. Let's do that. So we'll have S plus 7 plus 5 equals 2 times S plus 5. So notice we went from 2 variables, J's and S's, to simply 1 variable in this equation. So it's going to give us, let's see, S plus, combine the 7 and the 5, 12, equals, here we're going to distribute the 2, we're going to have 2S, and 2 times 5 is 10. if I wanted to solve this equation, let's get all the s's on the right-hand side. I'll subtract an s from both sides, and I'll get 12 equals s plus 10. And then I'll subtract 10 from both sides. I'll get that s is going to be 12 minus 2. It's going to be 2 years old. So Sam is going to be 2 years old. How do we find John's age? You take 2 years and we plug it back into this purple equation. When we do that, we'll get John's age. So John is going to be 2 years plus 7. So John will be 9 years old. Let's just check our work. So right now, John is 7 years older than Sam. Is that right? Yeah. John is 9. Sam is 2. So John is 7 years older than Sam. 5 years in the future, John will be twice as old as Sam. Let's see. How old will John be 5 years in the future? Let's see. 5 years future. Let's just check this. John's going to be 14, right? J plus 5 will be 14. And Sam in the future, S plus 5 will be 7. So notice that John's age, 14, will be twice Sam's age. So yeah, that checks out. So it's always good to check your work. You can do it mentally if you don't want to write it out. I like to write things out sometimes just to do it. Okay, so there are a couple of word problems that don't have any pictures. We'll do one more word problem coming up.